Good morning. Today we discuss about production of griseofulvin by fermentation method, which is come under in your syllabus. It is come under the unit 5 of fermented products. In your syllabus, you have to study about 5 fermented products like penicillin, griseofulvin, glutamic acid, citric acid, and griseofulvin. Okay. Today class we discuss about the fermentation product of griseofulvin. Okay. As we in previous unit we studied about different type of enzyme production by fermentation, right? Here we discuss about the production of griseofulvin. But do you know what is griseofulvin drug? Which category it is come under? Which category? Antifungal drug. Okay, so let's start with introduction. Griseofulvin is an antifungal drug which acts specifically on fungi with continuous cell wall which is isolated from penicillin species. Okay, it is an antifungal antibiotic drug isolated from penicillin species in 1939. It is also a secondary metabolite product of Penicillium griseofulva. Okay, then what's the use of griseofulvin? It is already said that it is an antifungal drug. Okay, it is mainly used for the treatment of antifungal diseases like skin fungal infection. Okay, then what is the mechanism of action? Currently, it is not known the mechanism of action, but it is believed that it will break down the chitin biosynthesis. What is meant by chitin? Chitin is an important material for cell wall composition. Okay, this chitin biosynthesis is adversely affected by griseofulvin antibiotic. Okay, this is the mechanism of action. Then currently the chemical synthesis of griseofulvin production is not done because of a higher cost. The production cost is very high due to chemical synthesis. Okay. So fermentation method is carried out. Okay. Here fermentation by aerobic submerged process will be noted. Okay. In enzyme production, we also note that the fermentation product have 4 steps. What are they? Selection of microorganism, formulation of media, production process, recovery and purification of enzyme. Here is the same steps, same 4 steps. Okay. First step, selection of microorganism. Mainly we use 2 type of microorganisms such as Penicillium griseofulvum and Penicillium patulum. High yield strain of Penicillium griseofulvum and Penicillium patulum will be used. Most commonly used microorganism. Okay. Also we used different types of microorganisms such as Penicillium nigricans, Penicillium urticae, Penicillium albidum, Quaskia oryzae, Nigrospora musae and Nigrospora sclerica, etc. These are the other fungal strains used in case of the production of griseofulvin. Okay. Then in case of laboratory scale fermentation, we can also use spore suspension as well as vegetative cells can be used. Okay. These are the microorganisms used for fungal production, used for griseofulvin production. Okay. First we got the microorganism, then we'll when we make a formulation media. In here for fungal cell production, the media for formulation development and fermentation and culture condition are quite similar. Same media will be used for this inoculum development, fermentation and culture media. Okay. Most commonly used in case of griseofulvin production, most commonly used medium is Capex Dox agar medium. Okay, Capex Dox agar medium will be commonly used for griseofulvin production by fermentation method. Okay, here is why this Capex Dox agar medium is selected for the griseofulvin production is that which can be rich in glucose and sodium nitrate as the nitrogen source. That is why we used Capex Dox agar medium in griseofulvin production. Okay. Here is the composition in Capex dox agar medium. Glucose, sodium nitrate, potassium hydrogen phosphate and magnesium sulfate. Here glucose is of the concentration of 5%, sodium nitrate of 0.2%, potassium hydrogen phosphate of 0.1% and magnesium sulfate of 0.05%. Here is the ingredients in Capex dox agar medium which is commonly used in griseofulvin production. Okay. Then we can also, for example, for griseofulvin production, the different medium are used for microorganism growth. That is sporulation medium, germination medium and seed stage medium. In sporulation medium, we can use ingredients such as whey powder lactose, whey powder nitrogen, potassium hydrogen phosphate, potassium chloride, corn steeper, etc. These are the ingredients in sporulation media. And in germination medium, we can use protopeptone, malt cereal extract, glucose, starch, sodium nitrates, dihydrogen potassium phosphate, magnesium sulfate and ferrous sulfate. And seed stage medium, we can use corn steep liquor, brown sugar, chalk and corn oil. Okay. And in medium composition for the production of antibiotics, the ingredients such as corn steep liquor, calcium carbonate, potassium hydrogen phosphate and potassium chloride. In this case, we can use the carbon source of 12% and phosphate of 0.5% will be used. We can also use chlorine because for better yield production. For commonly, we can use chlorine for better yield production. Okay, this is the formulation media. Then next step is the production process or known as production control. This in production control we have to incubate this inoculum. Okay, for inoculum we can in fermentation. We already said that here we can use aerobic submerged process. Okay. Nitrogen source will be supplied in the form of sodium citrate and we have to control the fermentation. Optimum condition will be controlled. Here the optimum condition of temperature will be as 23 to 26 degrees Celsius and pH of 6.8 to 7.3. And we already say that we can perform aerobic submerged process. Okay, aerobic submerged process means we have to supply, continuous supply will be provided. Okay, so here we can use the aeration speed of 0.8 to 1 volume per minute. And the maximum incubation period is that 7 to 10 days. We have to perform fermentation at least 7 to 10 days. Okay. Then after the incubation period, already after the fermentation, we get fermentation broth. From this fermentation broth, we have to separate the fermented product from other constituents. Okay, that is the recovery and purification steps. From this recovery and purification step, first we separate the broth from the fermented product by done pre-treatment of fermentation broth. This pre-treatment can be done by heating the fermented broth at 60 degrees Celsius for 20 to 30 minutes. Why this heating is applied? That it can be coagulated the material. Coagulation means we can separate it out the fermented products from other constituents. Okay, that is why heating will be applied or pre-treatment will be performed. We can also raise the temperature at 80 degrees Celsius by decreasing the time period of 5 to 10 minutes. Okay. After pre-treatment, we can separate the fermented products and other material constituents by coagulation. Then we can go for filtration method. In filtration, we can separate the mycelium from liquid constituents. Okay. Wet mycelium is collected from rotary drum discharge filter. This mycelium will be separated by rotary drum discharge filter. Okay, then we get the mycelium, we have to extract it. The solvent and liquid will be extracted by using butyl acetate or cold acetone as the extracted solvent. Okay, then we have to improve the color of the extract by using calcium hydroxide. If the extraction color is of a yellow shade or not purely white, we have to improve the color by adding calcium hydroxide. Okay. Then impurities and waxy substance are also present in that extract. So we have to wash the extract with a solvent of aliphatic hydrocarbons such as hexene or petroleum ether. Okay. Then that is why the impurities and waxy substance is removed. Then final esterification can be done by centrifugation method and concentrated the centrifugate material at the pressure of 50 degree Celsius. Okay, then we can get the fermented product, always griseofulvin product as in precipitated form. So we can be treated with chloroform or washing with chloroform. We get the precipitated product of griseofulvin in precipitated product of griseofulvin. Then we have to recrystallize the aqueous acetone. In this fermented product, this crystalline product can be recrystallized by using aqueous acetone. Okay, these are the 4 steps for the fermented products of griseofulvin. Okay, here is the flow chart for griseofulvin production. We can carry out the fermentation in fermented vessel. From the fermented vessel, we get the griseofulvin. After incubation, we get the griseofulvin product. From that mycelium, we can go for preliminary treatment, that is pre-treatment by heating. From the heating, we can coagulate the material as well as separated the material. And we can go for filtration. In filtration, we can separate the solid and liquid ingredients. From that, wet mycelium will get from in rotary drum discharge filter. Okay. From the filtration, solid and liquid ingredients will be separated. The solid ingredients we have to extract by using butyl acetate or acetone. Then further extraction carried out to remove the impurities or waxy substances. Okay, so further extraction can be done by petroleum ether or a hexane as the solvent. Then finally we get the partially purified antibiotic solution. From this partially antibiotic solution, we have to precipitate out the griseofulvin product, so we can add chloroform. Okay, from that recrystallization and purification can done. Recrystallization and purification done by using aqueous acetone. Okay, finally we got the antibiotic griseofulvin will be produced. Okay. Then what are the application of griseofulvin? As we know that griseofulvin is an antifungal agent. Okay, so we have to used in the treatment of various fungal skin infections. Okay, main use of griseofulvin is that used to treat various skin fungal infections. Okay, it is also used in the treatment of plant disease caused by biotristis and Alternaria solani. These two are the fungal disease affected in plants. So we can also use the griseofulvin in fungal diseases of plants. Then it used to treat the infections such as ringworm, athlete's foot, jock itch and fungal infection of scalp, fingernail and toenail. Okay, these are the application of griseofulvin. Let's conclude the topic. Okay, thank you.